Okay, now let's find the dot product and angle between those two vectors. And like I always say, the vector we can always write like this with an arrow. It means they are vectors. Well, if you didn't see this video, okay, or you can just pause the video and read, or you can just take and watch this video, okay? I'm not going to go into details, but I'm just going to say that for this exercise we just need this formula. It asks, well, find the dot product. The dot product, it is just that. Okay, this is a dot product formula. Okay, just multiply coordinate by coordinate, and then to know the angle between two vectors, it is a dot product between the products of their modules. Just that. There is a video specifically for that. I'm not going to go into details for this. Okay, and now let's just solve the exercise. Well, first let's just find the dot product. Dot product. The dot product between UV. This is a dot, it can't be a cross, okay? It's not cross product. Cross product between vectors is something totally different. Now between U and V it's going to be, you're just going to multiply. This is 4, this is 1, okay? This is coordinates I, J, and K. And if you remember, they are just describing that. This is I, J, and K to the top, okay? Now, it's just like saying X, Y, and Z. Okay, so let's multiply the Y coordinates, okay? So this is going to be 4 times 1. 4, there is no need to put these brackets. 4 times 1 plus 2 times minus 1 plus 2 times minus 1. I'm going to hide this, there is no need. This is 4 minus 2, this is just 2. So the dot product, it is just 2, okay? This is one answer. This is a dot product, just 2. Simple as that. And we're going to use the dot product to calculate the angle between those vectors. And because we know that the dot product, it is equal to, there's a dot in here, equal to the product between their models. I'm just using AB, okay, times the cosine of alpha. Okay, this is one vector, another vector. Those are the vectors. Now we just we can rearrange this. The cosine of alpha, it is just the dot product between those vectors divided by their modulus. Simple as that. Okay, so the cosine is going to be the dot product. We just have seen it is just 2, right? It is just 2 in here. Now the modulus for this one, for U, this is going to be square root of 4 squared plus 2 squared. 4 squared plus 2 squared. Multiply by the modulus for this other vector. It is just 1 squared plus 1 squared. This is going to be 2 divided by square root of 20, and this is square root of 2. If we just put everything together, this is going to be 2 over square root of 40, and 40 it is just 2 over 40, it is 4 times 10. 4 times 10, we just get away the 4. It's a 2, so it's 2 square root of 10. That 2 cancels with that 2. It leaves us with square root of 10 at the denominator, but we don't usually write square root at the denominator. To get rid with that square root, we just multiply by square root of 10. So let's cancel this, cancel with this one. Okay, so it's in the end, we're going to have square root of 10 divided by 10. Okay, so the cosine of alpha, it is that. And what is alpha? alpha, it is the inverse cosine of square root of 10 divided by 10. Okay, and if you just plug in into a calculator, okay, let's bring our calculator in. Now let's just plug in this. Alpha is going to be, okay, a cosine, inverse cosine, the arc cosine of square root of 10 divided by 10. Okay, make sure it is on degrees, because otherwise you're going to get radians, and then everything is in degrees. And what is the answer? It is just going to be in degrees. So the answer, it is going to be 71 degrees and 6. Okay, so this is degrees, and this is the answer. So that is the angle between those two. Okay, it's just like that. If we have U, we have maybe V, and the angle between them, it is just around 72 degrees. This is what is going on. Okay, the magnitude of U, it is a square root of 20, and the magnitude of V, it is a square root of 2. So V, it is smaller than U.